right, so as we move to online instruction, I'm going to start making more videos about different lessons and things that we're going to be discussing in Algebra 2. I wanted to keep things as similar as we could with you guys being at home. Really sorry that we can't meet in person, but it's just the way it's going to be for now. I wanted to start off by just talking about where we left off in Algebra 2 before all this craziness happened. So let's take a look. The last thing we did was multiply and divided rational expressions. I just want to remind us of a couple of things about this, because it's probably been a long time since you've done any math. But we were given a polynomial, and then we factored it. We factored the top and we factored the bottom. And then when we do that, we would end up with what you see here, as these two things were factored. And then what we were looking for is, we were looking for common stuff, a common set of parentheses on the top and on the bottom. And if you notice in this problem, we do have that. We have x plus 3 on top and we have x plus 3 on bottom. And what we said is that we can cross those out, and then it would become, since those are gone, it would become x plus 5 divided by x plus 7. Now keep in mind also, it's a temptation to want to just cross out those x's, but that is not something you can do. You kind of have to think of it as like these x and 5 are together. They're kind of like paired up. And so I can only cancel out the x if I cancel out the 5 with it. So if these two things are together, I cannot separate them. They have to be canceled out together. And so since this is x plus 7, I can't do that. Okay? And so that's basically where we left off before all the schools got shut down. But today, we're going to be learning about adding and subtracting rational expressions. And with this this is going to present some new challenges, because unlike multiplying and dividing, where you don't need a common denominator, you are going to need a common denominator in these problems. All right, and in order to figure out the common denominator, we look at the two denominators, the 9 and the 6, and we say, what is the LCM of 9 and 6? Well, what's the LCM? The LCM is the least common multiple. And what that is that is the smallest number, that's why least, that's the smallest number that 9 and 6 divide into evenly. And so if we look at that and we think, excuse me, what is the smallest number that 9 and 6 can divide into evenly? Now, this is something that we've done a long time ago in math. But if you think about it, if you look at the number 18, 18 can be divided by 9, and that goes in evenly, and 18 can be divided by 6, and that also goes in evenly. So that would be my least common multiple. And so now what we're going to do is we're going to change both of these into, excuse me, hold on one second here. We're going to change both denominators into 18. And so let's just change it to 18, and then we're going to say, okay, what did I have to multiply 9 by so that I got 18? And the answer to that would be I'd have to multiply 9 by 2 to make that an 18. And if you remember when you're working with fractions, in order to keep the fraction equivalent, you would have to multiply the top as well by 2, which would change our numerator to 8. And so that now is 8/18. We're going to do the same thing to 5 over 6. So what do we multiply 6 by to get to 18? And that would be 3. So again, we have to multiply the top by 3. And then we do 5 times 3, and that would give us 15. Well, now that we have a common denominator, we can just add the tops and keep the bottom. And so in this case, it would be 23 over 18. And that would be our answer. Now, those same principles are going to hold true with when you start throwing in polynomials. For instance, let's look at number 2. It says 3y over 2x plus 2z over 5x. So now what we're going to do is we're going to say, okay, I want to know what the LCM of 2x and 5x are. Well, now it's a little bit trickier when you throw a variable in there. But since they both have an x, they already have that in common. I don't need to worry about the variables. So now I'm just going to say, okay, what is the LCM between 2 and 5? And again, if we think about that, the LCM is the least common multiple. It is the smallest number that 2 and 5 will divide into evenly. And then you can always, well, what that answer is, the least common multiple between 2 and 5 would be 10. Since they already have the x in common, we're just going to say the LCM is 10x. All right, so again, we're going to change these to 10x, and we're going to change this to 10x. And then just ask ourselves, I have 2x here. How do I change that 2x into 10x? And the answer is I'm going to multiply that by 5. And again, we have to multiply the top by 5 also, just like in the last example. And that would give us 15y. We will repeat that same process over here, and we're going to multiply them both by 2. And that would give us, the top would change to 4z. Well, again, now that I have the denominators to be the same, I can now write this as, I'm going to add the top, however, they are not like terms, so all I can do is write them like that with a 10x on bottom. And then that would be my answer for that particular problem. Let's take a look at something a little bit harder, okay? So let's take a look at something like this. We have our third example would be 4 divided by x squared, let's not put a parentheses there, x squared minus 4x plus 3. And then on the right side we have x and then x squared plus 5x minus 6. Okay? And so in order to figure out what factors are on bottom, we will need to factor the denominators of both sides. So if you remember, we've done this a lot, but if you remember, we're trying to figure out what multiplies to the last term and adds up to the middle term. What we've done up to the side here is kind of done something like this. Multiplies to 3, adds up to negative 4. And in that case, it's going to be a negative 3 and a negative 1. That satisfy both of those little equations, those side equations we got here. So it'd be x minus 3 and x minus 1. Okay. On the right side, doing the same thing with just different numbers, we would have two things that multiply to negative 6, and those same two numbers have to add up to 5. Now be careful here, because it can be quite tricky with 6 and 5. So looks like it's going to be a positive 6 and a negative 1. So we put x plus 6, x minus 1. Okay. Now, if you notice, they actually do already have something in common, this x plus 1 and this x plus 1. Okay. What we want is them both to be exactly the same. The two denominators need to be all the same here and all the same here. So we have to add to the left side, we have to add here what's missing from this denominator down here. Okay. This is kind of like what we're going to be doing, what we did before, is when we added, back here, when we added that factor so that it matched the 10x. Okay. So we have to look over on the right side and say, okay, what does the right side have? Whoops. What does the right side have that the left side does not? Well, they both have an x plus 1, but this left side is missing an x plus 6. What we're trying to do again is we're trying to get the denominators to be the same. And to follow the same principles, I have to multiply the top and bottom by that x plus 6. And then we do the same thing over here. What does the left side have that the right side does not have? And if you look, the right side does not have an x minus 3. Okay? And so by the same token, we're going to multiply the top and the bottom by x minus 3. Now things are starting to get a little confusing, so let's rewrite this. Okay? I'm going to do it on another page here. So over here we have 4 times x plus 6. And then on the bottom we have x plus 6, x minus 3, x minus 1. X plus 6, x minus 3, and x minus 1. Plus, on the right side, we have x and x minus 3, and then all of the same stuff is on the right side as well. And what that allows us to do now is, now that the denominators are the same, I can add the two top stuff together. So it's going to look like this. 4 parentheses x plus 6 plus, and so now I'm basically just creating one whole fraction with all this stuff underneath. Now I need to simplify the top, so I'm going to do the distributive property here and here. So we're going to get 4x plus 24 plus, so 4 times x, 4x, 4 times 6, 24. And then we have distributing the x. X times x, that's x squared. X times negative 3, that's negative 3x. And then we have this x plus 6, x minus 3, and x minus 1. Now on the numerator, we're going to see if we can simplify that and then just put things in order so it looks nice. So we have x squared. There's no like terms with x squared, but we do have a 4x and a negative 3x, which would create a plus 1x, but again, we don't have to write that 1. And then we have the plus 24. And then we have x plus 6, x minus 3, and x minus 1. And with that, that is our final answer. Let me circle that a little bit better here. And that would be our final answer. I know that's a lot. I will make another video with some extra practice problems, but for now, we're going to call that good for adding and subtracting rational expressions.